In this module, we're going to see how to find the molecular formula of a compound. All right, so you have to know the molar mass. You have to be given the molecular mass or the molar mass of the compound in order to find the molecular formula. And you're going to see it two different ways. One, if you're given the percent composition, like we just calculated earlier, we can multiply the molecular mass by the percent of each element and then divide by that element's molar mass. And I'll show you with the dimensional analysis why this is, how it works out. So let's use an example. Okay. Suppose we have a compound and we know somehow its percent composition. There it is, 60% carbon, so on. And we know its molar mass. We have to know that, 540.48 grams per mole. Now let's find the molecular formula. So all you do is you take the percent, make it, just like we did before, make it in the 2 grams. So the 60% carbon means that there are 60 grams of carbon in 100 grams of the compound. And we know from the molar mass that there's 540.48 grams of the compound in 1 mole of the compound. And so you see that the units work out like this. Grams of the compound cancel out, and we get grams of carbon per mole of the compound. Now, all we do is take the grams of carbon in the 1 mole of a compound and divide by the molar mass of carbon. See, the units work out, grams of carbon cancel here, and we get moles of carbon per mole of the compound. That number, okay, you're going to round to a whole number, should be really close to a whole number. That's the subscript for that element, period. Because there's going to be 27 carbons in 1 molecule of this compound. Now let's go do the same thing for hydrogen. So we take 4.48%, 4.48 grams of hydrogen per 100 grams of the compound, times the molar mass of the compound. This tells us how many grams of carbon in 1 mole of the compound. So again, the grams of the compound cancel. And then we take the grams of hydrogen in 1 mole of the compound, divide by its molar mass, the molar mass of hydrogen right here. Moles of grams of hydrogen cancel, and we get moles of hydrogen per mole of the compound. And so we know in 1 molecule there are 24 hydrogens. Now, kind of shortening it up, kind of the way I do it if I'm in a hurry, just the percent is 35.53% oxygen, so 35.53 over 100 is 0.3553 times the molar mass, divide by the molar mass of the element. Same thing, 12 oxygens. And so that's kind of a shortcut without putting the units, but make sure you understand how the units work. And now that we know there are 27 carbons, 24 hydrogens, and 12 oxygens in 1 molecule, we can write the formula, C27H24O12. Now, the other way that you can be given a problem like this is if you're given, or somehow you know the empirical formula, and once more, you are given the molar mass or the molecular mass. So what you do is take the empirical formula, if this is the information you're given, and find the molar mass of the empirical formula. So that's what I did here. 9 carbons, 8 hydrogens, and 4 oxygens. Added them all up, and I got this number right here. We're given the molar mass. All you do is take the molar mass, divide by the molar of the compound, and divide by the molar mass of the empirical formula, round to the nearest whole number. It comes really close to 3. And what that means is you multiply each of these subscripts in the empirical formula by this number here, in this case by 3. So 9 times 3 is 27, 8 times 3 is 24, 4 times 3 is 12, and that gives us our molecular formula.